The universe of Fred Hoyle. 3 scientists named Fred Hoyle could have entered the history of science. One was among those immortals whose names are reverently listed alongside Einstein, but the time for others has not yet come. The second was adored by journalists, always ready to throw them a couple of ideas that would be debated for years. These are the ideas and hypotheses that, while they always nourish science, certainly spur it on and make it develop. Finally, the third was, to be honest, an unsuccessful scientist who probably long considered himself a journalist and writer at heart. He sprinkled witty paradoxes and must have spent all his talent on this. 3 scientists, 3 fates, 1 person. Englishman Fred Hoyle, who lived from 1915 to 1984, was a very different and ambiguous person. It was as if he lived 3 lives, or maybe more, in the years allotted to him. He is called one of the greatest astronomers of the 20th century. His ideas were brilliant. He truly revolutionized science. He is considered one of the strangest scientists of the 20th century. His ideas were often absurd and erroneous. And perhaps, in the grand scheme of things, he was not even a person but a machine for producing ideas. A printer on the neighboring table doesn't care what it prints. Sometimes it seemed that Hoyle didn't care what he told his colleagues, as long as the idea was unusual. Thus, he was a diligent creator of scientific theories and scientific myths. Referring to his first incarnation, it is enough to say that in 1957 Hoyle published a classic work on the thermonuclear synthesis of chemical elements in the cores of stars. His co-authors were astronomers Margaret and Geoffrey Burbage and physicist William Fowler. Before this, no one could explain where the world around us came from. After all, the phrase "the world was born in the flames of the Big Bang" is just a beautiful, crackling phrase. During the Big Bang, only 2 chemical elements arose, hydrogen and helium, not our entire world. No one could understand by what alchemical miracle helium turned into calcium, nickel, boron, and so on, and hydrogen split into carbon, oxygen, and fortunately not phlogiston. As brilliant as this achievement was, his failure in another area of astronomy was equally striking. In the 1920s, several scientists, Einstein, Friedman, Lemaitre, Hubble, came to the same idea by different paths. We live in a universe that is rapidly expanding. Obviously, it was once the size of a primordial atom. Hoyle considered this nonsense. In 1949, speaking on the BBC radio station, Hoyle parroted this picture of the birth of the universe, contemptuously calling it the Big Bang. The meaninglessness of these sounds, it seemed to him, emphasized the absurdity of what was happening. But it turned out that he invented not a curse, but a new brand. The theory that angered him gained even more followers. Hoyle himself advocated for another theory, the steady-state theory, which he developed a year earlier along with Hermann Bondi and Thomas Gold. In this theory, the universe expanded but expanded forever. It had no beginning. Thus, the question of what existed before the Big Bang elegantly fell away. But a new question arose. If my desk started to expand, soon I would no longer find my notepad or pen. They would be far ahead. In other words, if the universe is expanding forever, its space must be mostly empty. Hoyle proposed, without hesitation, that in the void, spontaneous matter creation occurs at a rate that keeps the average density of the universe constant. From this matter, new stars and galaxies gradually form, filling the gaps between the old ones that are flying apart. This theory, at the time of its appearance, claimed to become the foundation of cosmology. Indeed, it was hard to refute. Most scientists abandoned it only after the discovery of cosmic microwave background radiation in 1965, predicted by the Big Bang theory. The Big Bang Theory became the standard model of cosmology. Another favorite topic of Hoyle, the scientific heretic, was the origin of life on Earth. If we live in an eternal universe, then life, along with space and time, might be an intrinsic property of the cosmos. In the 1970s, with the development of space exploration, interest in the panspermia hypothesis, life transfer from one celestial body to another, was rekindled. Hoyle, along with his student Chandra Wickramasinghe, born in 1939, published numerous articles advocating this unusual view. The universe abounds with life. These works brought Hoyle scandalous popularity. The panspermia idea was rejected by both astrophysicists and biologists. Theologians embraced it, but Hoyle and Wickramasinghe calmly developed their views. Here's what they believed. In space, myriad spores of bacteria roam. Some lie dormant in comet nuclei, the Noah's Arks of evolution. Others are packed in meteorite fractures. Still, others cross the cosmic ocean without any transport means. They float, unprotected by anything but dust. They float and survive. When these spores enter a hospitable environment, they rapidly multiply, turning deserts into blooming gardens. This is how the story of life on Earth began. Hoyle and Wickramasinghe substantiated their hypothesis with the results of the spectral analysis of cosmic dust. Its infrared spectra closely resemble those of organic matter, particularly dry bacteria. Subsequently, observing the radiation from distant galaxies, Wickramasinghe concluded that microbial spores could travel even from one galaxy to another. According to Wickramasinghe's estimate, there are about 33 tons of microorganism spores circulating within the Milky Way alone, moving from one planet to another, from one star to another. A fleet of astronomical proportions travels through space, deploying spores on every solid surface along the way. Encased in spore capsules, these primitive organisms, unlike the pinnacle of creation that is man, can travel through stellar worlds for millions of years. Pathogenic microbes and viruses might also enter from space with comets. According to Hoyle, plagues, HIV, and rabies were brought to Earth from space. Here, science quietly transitions into pure fiction for the readers. The ideas and hypotheses posited by Hoyle can no longer be experimentally verified with the means we have. They must either be believed or perceived as science fiction. Hoyle also wrote science fiction. In The Black Cloud, he portrayed an unimaginable scenario. He described a seemingly ordinary gas and dust cloud stretched out in space. However, under his pen, it turned into a gigantic living creature. Thinking clouds could communicate with each other, reasoning and summarizing, sending directed radio signals to their counterparts. Perhaps we are already living surrounded by these intelligent extraterrestrial beings, which seem to us merely dead parts of the surrounding world. Endowed with extraordinary creative power, Fred Hoyle was brilliant in his insights. What if those conjectures that seem to us today as scientific myths become new scientific truths tomorrow? The myth of aliens. They have long inhabited the dreams of poets and the utopias of thinkers, philosophical novels and fantasy stories, myths and fairy tales. Sometimes they save people, sometimes they scare them, sometimes, like gods, they reveal the greatest secrets. Sometimes, driven by satanic passion, they try to destroy us. Over the millennia, humanity's collective mind seems to have thought through every scenario of the Great Contact. Encounters with aliens, our brothers in mind or our adversaries, natural competitors in the struggle for a place under the starry sky. The great philosopher Immanuel Kant, who spoke with awe and admiration of the starry sky above and the moral law within us, was convinced that the neighboring planets of the solar system are also inhabited by intelligent beings. And the farther the planets are from the sun, the more intelligent their inhabitants. Belgian biochemist Christian de Duve, Nobel laureate in medicine in 1974, considered life to be a cosmic inevitability. Another Nobel laureate in 1965, molecular biologist Jacques Monod, on the contrary, believed that man is the only intelligent being accidentally arisen among the indifferent vastness of the universe. The opinions of astronomers vary just as widely. Some say that the cosmos abounds with life. Their opponents set so many conditions restricting its origin and development that in their models, Earth is lost in a lifeless desert where neither we nor our descendants will find anyone. Debates about extraterrestrial life are so barren, scientific discussions so contradictory, that encountering various views on this scientific problem, finding oneself literally at the crossroads of opinions, feels like a dead end. The problem is so speculative that one feels the acute lack of solid facts underfoot. In this abyss of our ignorance, it is so easy to give up hope, to resign oneself, to disappear. Since the dawn of the cosmic era, when our spacecraft ventured into open space, we have not found any extraterrestrial organisms, alien artifacts, or even traces of vanished life. The only thing we managed to gain after all these fruitless searches and debates is a plan of action for the coming decades. Here are the main focal points that may allow us to catch extraterrestrial life off guard, scare it, or even convince highly developed civilizations, if they exist, to pay attention to us. Radio exploration, limited to the size of the solar system, now makes us understand that the catch here may only be of microscopic size. After all, science generally permits the possibility of microorganisms existing on Mars and the moons of Jupiter and Saturn, either in the present or distant past. The second focus is on exoplanets. It seems only recently, a couple of decades ago, that the discovery of the first planet outside the solar system in the Pegasus constellation became a worldwide sensation. Since then, the count of distant planets has reached thousands, and no one is surprised anymore when a new planet, close in size to Earth, is regularly discovered by astronomers. New generations of telescopes will allow us to routinely perform spectral analysis of the atmospheres of exoplanets within a few dozen light years from Earth in the coming decades. Knowing the composition of an atmosphere can tell us whether such planets might be habitable. But true success can only come with a third focus. It's like the third call in a theater. After it, scientists hope the heavenly curtain will open and we will see the main actor on the world stage, extraterrestrial intelligence, revealing its presence. Like Immanuel Kant and many other great and not-so-great minds before and after him, we dream not so much of finding lower biological life on other planets and super-Earths, but of finding extraterrestrial intelligence, older brothers in intelligence, whom we hope will help us rise to the heights of civilization. But are our dreams in vain? Are we really alone in the universe? We have already heard extreme opinions. But can we reasonably assess the likelihood of the existence of advanced civilizations in the Milky Way and other galaxies? Let's look into the recent calculations of some scientists. American astronomers Peter Beruzzi and Molly Peoples showed that most planets formed very long ago. The age of 80% of planets resembling Earth and 50% of gas giant planets is at least 4.6 billion years, meaning they are older than the solar system. In our galaxy alone, there may be up to 1 billion Earth-like planets and up to 10 billion gas giants. Based on this assumption, Beruzzi and people suggested that there are many thousands of civilizations in the Milky Way. Adam Frank of the University of Rochester in New York and Woodruff Sullivan of the University of Washington in Seattle estimated the number of stars in the observable universe. It came to almost 23. If we consider that about a dozen planets revolve around the star named Sun, the probability that we are alone in the universe is about 1 in 24. There is no direct answer to the question, are we alone in the universe? But the unnaturalness of this figure suggests a negative answer. And if we venture beyond our own galaxy, extraterrestrial civilizations are ready to be discovered even by hardened skeptics. A few years ago, American scientists, astronomer Michael Hart and physicist Frank Tipler, suggested that our civilization might be the only one in the Milky Way. However, they had to agree that in any of the countless other galaxies, there must be at least one inhabited planet where a technological civilization may have developed. The distances separating our stellar islands are so vast that all extraterrestrial civilizations are forever isolated from each other. But can we detect any real signs of the existence of aliens today? Long ago, with the advent of radio, scientists pondered that if there were intelligent life beyond Earth, it might reveal itself through radio signals. In 1960, American astronomer Frank Drake used a 26-meter radio telescope at the National Radio Astronomy Observatory to monitor signals, potentially coming from two stars, Tau Ceti and Epsilon Eridani. Since then, our telescopes have repeatedly observed various parts of the sky, attempting to intercept signals from extraterrestrial civilizations. However, all efforts have been in vain. This does not mean that such signals do not exist or cannot exist. It means that the task is much more complex than initially thought. We do not know where to expect a signal. The universe is unimaginably vast, and the range of frequencies on which we should listen for radio intercepts is also very large. In addition, space has many natural radio sources that confuse scientists. Finally, no one knows what exactly we are looking for. Do aliens use radio waves to exchange information? Or have they developed fundamentally different communication methods? Meanwhile, we are reaching a new level of search. In 2015, with funds from Russian billionaire Yuri Milner, the Breakthrough Listen initiative started. By 2025, its participants aim to study the surroundings of 1 million stars, including several thousand stars located near the Sun. Scientists are interested in any signs of artificial processes, i.e., technical activities of star world inhabitants. Now astronomers have at their disposal two of the largest telescopes in the northern and southern hemispheres. The Robert C. Byrd Green Bank Telescope in West Virginia, with a parabolic mirror over 100 meters in diameter, and the Parkes Radio Telescope in southeastern Australia, with a diameter of 64 meters. Have aliens visited the solar system? Conversations about family, work, cars, sports, and hobbies are common topics. However, in the summer of 1950, when two famous physicists, Nobel laureate Enrico Fermi, 1901 to 1954, and hydrogen bomb father Edward Teller, sat at the same table in the Los Alamos cafeteria, their chat might have seemed like a lofty fantasy to nearby diners. They were discussing interstellar travel, the unique opportunity to dash from star to star as if traveling from one end of America to the other. In different parts of the USA, UFOs, machines of alien visitors, were indeed being spotted. People were deceived, believed, and deceived again, but their appearance, like any phenomenon, could be theoretically explained. Suddenly, Fermi interrupted his colleagues' musings with a question. Where is everybody? Thus, the Fermi paradox was first articulated. Calculations have shown that if an extraterrestrial civilization reached a level where space travel became possible, It would only take them a few million years to explore the entire galaxy, visiting every possible location. Fermi addressed this issue to the delight of pessimists and skeptics. Since no signs of extraterrestrial life have been found, it must simply not exist. Otherwise, the galaxy would have been settled long ago, and our solar system would have been a resource colony of the great Milky Way civilization. In the late 1980s, British astrophysicist Martin Fogg suggested that our galaxy was fully explored by aliens even before the solar system formed. According to his idea, if even one of the civilizations here learned to make interstellar travel, systematic colonization of space would begin. Following this logic, all planetary systems near the solar system would have long been settled by aliens, and our cosmic home would have attracted their interest from the beginning. Their astronauts would have been here, observing individual planets, especially the terrestrial ones. Perhaps they even left behind monitoring devices, watching the local fauna, watching us. They know about us, but where are they all? You might echo Fermi's question. Where is everybody? Where are the traces of millions of people who lived on Earth in the distant past? Traces of Trojans and Hittites, Olmecs and Phoenicians, Neanderthals and Cro-Magnons, resting in the Earth? The idea of searching on Earth for artifacts left by aliens supposedly visiting in ancient times is not new. Erich von Däniken and his followers discredited it long ago with their excessive discoveries. In the spring of 2017, scientific circles rekindled interest in this ridiculed idea. Astrophysicist Jason Wright from Pennsylvania State University published an article on a popular science site addressing this controversial idea. What if, in the distant past, an advanced civilization existed in the solar system? Or perhaps emissaries of distant civilizations visited here? Could traces of their existence be found after possibly hundreds of millions of years? If so, where should we look? Where could extraterrestrial artifacts have settled? In the film 2001, A Space Odyssey, a mythical documentary as director Stanley Kubrick called it, the distant ancestors of humans suddenly discover a mysterious monolith, a black stone obelisk. Millions of years later, astronauts find the same monolith on the moon. Of course, for this fantasy suddenly gaining ground, one might earn the harshest criticism. Therefore, it is necessary to emphasize that Wright does not believe that an extinct civilization ever existed in our solar system. He is merely asking where in the solar system there is the highest probability of finding traces of such an extinct civilization, and where should we not look? Wright's idea may seem unscientific, but we have no facts to prove that aliens never visited our planet in the distant past, nor are there any traces of their presence here. This idea can be dismissed as pure fantasy, but it cannot be definitively proven as nonsense. If we mentally move beyond the confines of Earth to other planets, our keen eye, sharpened by the cosmic era, can easily identify several celestial bodies where aliens might have once settled. So where? On Venus, which in the distant past had conditions not much different from our planet. However, 500 to 800 million years ago, Venus underwent a series of grand volcanic eruptions. Powerful lava flows then concealed any traces of life. It would be much more interesting to search for signs of alien presence on Mars. The surface of the red planet is not fractured into dozens of lithospheric plates rushing for recycling. If an alien settlement was once built there, its ruins would be hidden under a thick layer of dust, but would not disappear. On the contrary, the ruins would be well preserved. Of course, our artificial probes have visited Mars many times, but they found nothing like our fantasies. Perhaps this is because we have been trying to find signs of current, contemporary life on Mars. No special equipment has been used to search for artifacts deep in the Martian soil. The traces of visiting space expeditions might even be found on the nearby moon, and even more so at the outskirts of the solar system, on asteroids in the Kuiper Belt. According to Wright, these small planets might someday reveal ancient mines and quarries left by someone other than humans. Maybe asteroids were used as cosmic beacons, warning signals to remind passing starships that venturing here to the sun is risky. Thus, perhaps billions of years ago, aliens visited certain planets in the solar system, including Earth, driven by the same curiosity that pushes our explorers to conquer the moon, colonize Mars, and settle on several planets at once. In other words, to soar above Earth. The same unknown instinct probably stirs a restlessness in a caterpillar before it turns into a butterfly. There might not only have been isolated, robotic alien bases in the solar system, but also entire networks of their settlements on various planets and moons, which were later abandoned or perished. Evaluating our activity in conquering the surrounding cosmic space, we cannot help but understand that any other civilization that emerged hundreds of millions or billions of years ago within the solar system, or penetrated into it, would behave the same way. However, over this time, the appearance of Earth, for example, has changed so much that the presence of aliens here in the distant past can only be suspected by some strange isotope ratios. So perhaps amazing discoveries await cosmic archaeologists on the Moon, Mars asteroids, or moons of giant planets. Planet Vulcan. In the 19th century, astronomers discovered that Mercury's true orbit differed from the ideal ellipse predicted by Kepler's laws. After completing an orbit, Mercury did not return to its starting point. In other words, its perihelion, the closest point to the Sun, shifted slightly with each orbit. How could this be explained? On January 2, 1860, Urbain Le Verrier, one of the co-discoverers of Neptune, proposed a convincing hypothesis during a lecture in Paris. He suggested that there might be a planet smaller than Mercury or a ring of asteroids between the Sun and Mercury. Due to their proximity to the Sun, these celestial bodies were difficult to observe and could only be seen during a solar eclipse or when passing across the Sun's disk. Months before his lecture, Le Verrier received a letter from amateur astronomer Edmund Lescarbault, who reported seeing a round black spot crossing the Sun's disk on March 26, 1859, resembling a planet. Lescarbault observed the spot for 75 minutes as it crossed almost a quarter of the solar disk, noting the inclination of its orbit. Using this data, Le Verrier calculated the orbit of this planet, determining it to be 19 days and 7 hours and 7 times closer to the Sun than Earth. Its diameter and mass were much smaller than Mercury's, making it too small to explain Mercury's orbital discrepancies. Le Verrier named this mysterious planet Vulcan. Another correspondent, Professor Rudolf Wolff of Zurich, also observed strange spots on the Sun, suggesting the existence of planets moving in 2 distinct orbits with periods of 26 and 38 days. Observing objects within Mercury's orbit was challenging due to the Sun's bright light, which could damage telescope optics and pose a risk to astronomers' eyesight. For over half a century, astronomers attempted to find the hypothetical planet Vulcan. In 1860, a solar eclipse in Spain offered a chance to observe Vulcan, but it remained elusive. Le Verrier continued to believe in Vulcan's existence until his death, and shortly before his passing, a German astronomer named Weber observed a round spot on the Sun on April 4, 1875. Calculations suggested that both Le Verrier's and Wolff's predicted planets crossed the Sun's disk the previous day, aligning to form Vulcan. On July 29, 1878, during another solar eclipse, University of Michigan astronomy professor James Watson observed 2 bright points, possibly small planets between Mercury and the Sun. However, American astronomer Lewis Swift only saw one star-like object, Vulcan, in a different location than Watson's observations. The discrepancies in their observations led to doubts about Vulcan's existence. By the early 20th century, most astronomers began to doubt Vulcan's existence. In 1916, Einstein published his general theory of relativity, explaining Mercury's orbital peculiarities without the need for additional planets. According to Einstein, the Sun's gravitational field warps space, altering planetary orbits. Describing Mercury's motion using Newtonian mechanics in Euclidean space makes it appear to move too quickly. However, if we refer to Euclidean geometry and Einstein's theory, the anomalies disappear. The difference in calculations is the same 43 arcseconds that once prompted Leverrier to invent the planet Vulcan. Now it had to be discarded. In May 1929, German astronomer Erwin Freundlich traveled to Sumatra to observe a total solar eclipse to provide final clarity on the prolonged debate. Later, he carefully examined all the photographic plates, revealing many stars that shone in the dark daytime sky, but there was no sign of the planet Vulcan. The last surge of interest in this planet occurred almost half a century ago, in 1970, when several astronomers reported seeing unknown objects near the Sun during a total solar eclipse. For instance, American astronomer Henrik Curtin was confident that he had proven the existence of the planet Vulcan. According to his calculations, Vulcan orbited the Sun in 11 days, at a distance of 0.96 astronomical units. However, the discovery was not confirmed this time either. For many decades, astronomers repeatedly observed this planet. What did they actually see? Lescarbault likely did not fantasize about his discovery. He reliably reported it, and a respected astronomer like Leverrier believed him. Modern researchers suggest that Lescarbault might have accidentally noticed an asteroid passing near Earth. Today, such asteroids are discovered almost annually, but they were unknown back then. Seeing this mysterious object against the Sun, Lescarbault thought it was a planet closer to the Sun than Mercury. Other researchers might have seen an asteroid crossing the Sun's disk, although no similar cases have been recorded to date. Experienced astronomers like Swift and Watson, obsessed with finding the planet Vulcan, might have mistaken stars for Vulcan during a solar eclipse. In Watson's case, it is proven that he mistook the stars Theta and Zeta from the constellation Cancer for planets. Curtin likely mistook a comet near the Sun for Vulcan. Subsequently, astronomers often observe comets approaching the Sun. Finally, some errors could be due to optical defects, leading amateur astronomers to mistake spots for unknown planets. Where are the Martian canals? The popular mind has long dedicated Mars to the god of war. Its red appearance seemed bloodstained. In the late 19th century, the bloody Mars suddenly became the planet of life. In 1877, Italian astronomer Giovanni Schiaparelli, with exceptional vision, noticed strange thin lines on Mars. He called them canali, meaning channels in Italian. They connected dark spots, Martian seas, or stretched towards polar caps. Schiaparelli believed that the channels were natural depressions, possibly giant riverbeds linking various water bodies. Soon, there were guesses that these riverbeds were artificial constructions dug by Martians. The channels started in Mars's polar regions. Apparently, in hot summer months, when the ice melted, water flowed through the channels to the dry southern areas, irrigating fields cultivated by hard-working Martians. One problem: if humans could see the channels, they must be several hundred kilometers wide, otherwise they wouldn't be noticeable. Who would dig such wide channels? American Percival Lowell, who founded an observatory in Arizona in 1894 specifically to observe Martian canals, offered an answer. He claimed that banks covered in lush vegetation lined the canals, sharply contrasting with neighboring desert areas. Lowell built the observatory to study our fellow beings, transforming Mars's nature at their will. Gradually, he mapped the Martian canals, counting about 700, forming a geometrically regular network. Unlike serpentine earthly rivers, they were drawn like straight lines. Believing that intelligent beings built them became inevitable. At the turn of the 19th to 20th centuries, few, even among astronomers, doubted that Mars was inhabited. The human-like world on Mars had likely advanced far beyond us in all aspects, wrote French astronomer Camille Flammarion. Martians built cities and mastered various arts. People believed in Martians as fervently as some believe in UFOs today. Articles in popular newspapers and magazines were dedicated to them. Their lives became subjects of famous writers' books and popular plots in mass literature. In 1898, H.G. Wells wrote The War of the Worlds, a chronicle of battles with Martian invaders. In turn, Alexei Tolstoy's characters from his novel Aelita, written in 1922-23, enthusiastically set off for Mars. Later, we would see Ray Bradbury's The Martian Chronicles in 1950 and Isaac Asimov's The Martian Way in 1955. Our fantasies about Martians are responsible for the canonical image of aliens, the little green man with antennas on his head. This character first appeared in a comic book in 1913, naturally dedicated to the adventures of a Martian. Most often, sci-fi writers hurried to assure the reading public that Mars was inhabited by treacherous, evil beings, always plotting to attack the timid, trusting Earthlings and seize their abode. A mass panic that gripped thousands of Americans in 1938 is still alive in memory, albeit as a curiosity. A regular radio broadcast was interrupted by an announcer reporting that a giant cylindrical object had crashed in New Jersey. The next news was alarming. A huge creature with many tentacles emerged from the cylinder's wreckage. More monsters were coming out, and they began attacking people. Everyone was terrified. Panicked citizens mistook the brilliant dramatization for a real report on the invasion of Earth's domain by the Martian colonial army. Unbeatable enemies, as tall as skyscrapers, mercilessly spewed fire, mowing down the unfortunate Yankees like grass. In horror and despair, people fled from their radios and jumped into their cars, driving anywhere their eyes led them. Some even tried to end their lives rather than wait for the invaders' arrival. American director Orson Welles, the mastermind behind the controversial broadcast, did not expect such success, which turned from a triumph into a psychosis. It's amazing that this enthusiasm and these fears were largely caused by an optical illusion. The human brain is accustomed to replacing rows of dots or dashes with solid lines. Today, people are sometimes ready to accept any atmospheric phenomenon as a UFO. In the early 20th century, any dots, spots, or streaks noticed on Mars involuntarily merged into a coherent network of canals. Throughout time, supporters of the most bizarre hypotheses have been ready to replace facts with their beliefs and fanatical faith. As Stanislaw Lem said, and yet, when you look at these magnificent maps by Schiaparelli, it's hard to believe he saw something that didn't exist, and that the most peculiar observers after him also saw it. It was some kind of psychological phenomenon. Subsequently, it interested no one anymore. Still, a significant part of the channels drawn by Schiaparelli and other astronomers were not figments of their imagination. They were real topographical details, later discovered on Mars. Grand canyons, valleys, terraces, depressions, or strings of craters stretched far into the distance. For example, the Valles Marineris Canyon extends almost 4,500 kilometers. Its width in places reaches 700 kilometers, and its depth varies from 2 to 7 kilometers. Schiaparelli and his followers undoubtedly saw this canyon. By the 1930s, the belief grew that there were no canals on Mars. They were optical illusions. In the early 1940s, American astronomer Fred Whipple wrote in his book Earth, Moon, and Planets, "We are unable to detect signs of intelligent life on Mars." The reader can form their own opinion. If they believe intelligent beings could have developed on Mars, they must imagine that these beings continued to exist for countless generations in a thin atmosphere, almost devoid of oxygen and water, on a planet where nights are much colder than our Arctic winters. The existence of intelligent life on Mars is not impossible, but it is entirely unproven. However, only after the American Mariner 4 probe sent photographs of Mars in 1965 did speculation about life there end. For the first time in human history, we saw photographs of another planet taken from close range. On these 22 photos, Mars's surface looked more like the Moon than Earth. This was a bitter disappointment for all who, after the discovery of Martian canals in the late 19th century, believed there might be some life on that planet. Mars had no irrigators, no grand fruits of their labor. There were no canals. Initially, Mars was almost excluded from the list of objects to be studied with space probes. However, for over half a century, its research has continued successfully, including with the use of rovers. And more often, politicians and business people speak about the first manned flight to Mars happening this century. Solar spots and economic crises. External factors undoubtedly influence the economy. However, scientists rarely admit that the entire world economy could be governed by a natural phenomenon, as if by an inexorable law. This was the case with the theory of British economist William Stanley Jevons, 1835 to 1882, considered the founder of the mathematical school in political economy. For several years, Jevons, known for his rigorous work, pursued a seemingly unsuitable hobby for a professor, observing solar activity and comparing it with economic conditions. This hobby resulted in several works, including the article Commercial Crises and Sunspots, published in Nature in 1878. In these works, Jevons tried to explain how events on the sun set the entire economic machine into motion, causing it to shudder in crisis. His arguments were consistently unconvincing, and he never derived his mathematically precise law. Jevons was one of the most versatile economists of his time, author of the famous books The Theory of Political Economy, 1871, and The Principles of Science, a treatise on logic and scientific method, 1874. Despite his brilliance, Jevons's interest in sunspots often attracted ridicule for his perceived frivolity and lack of scientific seriousness. Let's attempt to understand Jevons's logic. He assumed that the economy is a balanced system based on the mechanics of utility and self-interest. Small deviations from equilibrium are immediately smoothed out. Large fluctuations and crises are impossible, just as a pendulum cannot suddenly start spinning around its axis. However, the economic pendulum, with alarming frequency, defies these rules, with economic crises regularly occurring. Thus, reality contradicted the theory. What if the cause is unrelated to the economy? In the mid-1870s, Jevons, who had been passionate about meteorology since his youth, considered the impact of weather. With persistent effort, he tried to understand the connection between unpredictable, variable weather and a theoretically stable economy. Suddenly, he realized that meteorology, like economics, had its fluctuations. These could be compared to economic cycles. To explain how a crisis begins and how celestial machinery disrupts the established mechanism of earthly life, Jevons had to become a storyteller. carefully crafting a chain of imagined events that would inevitably lead to rising prices and market panic. He proposed the following scenario. Sunspots appear regularly. The sun dims, shining weaker. Weather worsens, crops fail, and prices rise. On the stock exchange, the future appears bleak and worrisome, and many people's fortunes decline. Economic crises and solar activity are recurring events. One follows the other. After the sun dims, economic life darkens, and a crisis ensues. The logic seems sound, but is it inevitable? Jevons turned to historical facts and was met with disappointment. In 1740, England, based on previous solar activity, should have experienced a severe crisis. However, it did not. Why? Maybe because the world's trading center was not England at the time, but Holland. Jevons even sent a letter to his acquaintance, economist Vissering, to help with archival research and determine if there had been a crisis. The response was discouraging. I found no evidence. Perhaps a crisis did occur but was forgotten. Nevertheless, this setback did not deter Jevons from his initial hypothesis. In his view, solar activity caused economic crises, setting off a chain of events culminating in market crashes, soaring prices, mass bankruptcies, unemployment, and hunger. Assuming his model was correct, the mistake lay in choosing the wrong crisis indicator. A crisis always begins with some event that sets a gloomy tone and foretells worse times. Every time, it is a unique event. Once, it was a rapid rise in wool prices. Another time, the proliferation of insurance companies. And another, newspapers suddenly warned of an impending crisis, which then occurred. Finally, Jevons decided to focus on grain prices. If they rose quickly, one should brace for the worst. Jevons selected grain prices in India, where demand was particularly high. Even a slight increase was acutely felt by the population. Additionally, India, a backward country relying on agriculture, was always vulnerable to poor weather. A crisis in British colonized India would inevitably affect the entire European economy. For Jevons, his hypothesis was important because solar activity as the primary cause of economic crises continually reminded him of its significance. As sunspots grew, one had to prepare for the worst, reflecting the inexorability of a fundamental physical law. Knowing the number of sunspots made it possible to predict consequences and the timing of a crisis. Contemporaries considered Jevons's theory a professor's eccentricity. Today, economists take it much more seriously. For example, American economic historian Philip Morosky believes that, in developing the sunspot theory, Jevons was perhaps making a final attempt to save the neoclassical market model. It seemed perfect, and any crisis within it could be explained by the random influence of external factors. Jevons's mistake lay in trying to explain the existence of economic cycles with a single cause, an exogenous one, unrelated to economics. Jevons himself noted, and later Arnold Toynbee agreed in his book A Study of History, that periodic economic downturns are inherently psychological, depending on changes in spirit, optimism, excitement, disappointment, and panic. And yet, it is impossible not to acknowledge that Jevons was partially right. We all live under the sway of the sun that shines above us. We become wildly energized when echoes of distant storms reach us, and we seem to hibernate, dropping everything once the sun calms down. Its energy fuels humanity, and its lack of energy often hinders decisive actions. Not only humans, but all living things on our planet, including the planet itself, react violently to processes occurring on the sun. It seems that during periods of high solar activity, the number of causes leading to the spread and intensification of epidemics increases, as noted by Russian scientist Chizevsky. The statistical data he gathered continued to find new confirmations. Like Jevons before him, many have studied the dependence of earthly processes on the state of the sun, but only Chizevsky presented heliobiology as an independent field of knowledge. He brilliantly demonstrated that fluctuations in solar activity influence mass behavior, thereby affecting the timing of social phenomena that make up the public life of human communities. Not everything depends on the sun, but much does. The inner cosmos of Earth. In the autumn of 1869, an American named Cyrus Teed, 1839 to 1908, was conducting an alchemical experiment trying to turn lead into gold. However, due to an oversight, he received a strong electric shock that knocked him off his feet. At that moment, he had a revelation. While lying unconscious, he envisioned an extraordinary view of the world that contradicted the beliefs held by generations of astronomers. Earth was indeed a sphere, but it was hollow. People lived not on the outer surface, but inside the sphere, filled with sky and celestial bodies. Why had no scientists from Galileo to Herschel noticed this? Because they all assumed that light travels in a straight line. If this is not the case and light rays bend, the observer perceives the revealed cosmos as infinite. The vision shown to the half-dead Teed shattered this illusion, leaving the rest to be deduced. The thickness of the Earth's crust beneath our feet, Teed now proclaimed, was only 100 miles, 160 kilometers. The diameter of the sphere we are enclosed in, like chicks in an egg, was just 8,000 miles, 12,875 kilometers. Inside the Earth sphere, there were 3 more transparent spherical layers. A layer of atmosphere directly adhered to the Earth's inner surface, followed by a hydrogen layer and finally a boron layer in the middle. How then to explain the mystery of the sun? After all, it shone brightly in the sky, disrupting the harmony of the spheres. In his book, The Cellular Cosmogony, or Earth a Hollow Sphere, published in 1898, Cyrus Teed wrote, "The sun is an invisible electromagnetic source of energy located at the center of the hollow sphere and rotating around its axis. What we see is merely its reflection. Like the moon, the sun is only a few thousand kilometers from the concave surface of the Earth. The sun's size is small. As for the planets and stars adorning the sky, they do not exist. They are merely numerous reflections of sunlight. The sun, like the legendary Janus, has a bright and a dark side, completing a full rotation around its axis in 24 hours, turning to us alternately with its bright and dark sides, hence day and night." Teed explained the seasons similarly, shocking astronomers. Physicists were outraged to learn that only light rays heading directly to the center of the hollow world travel in straight lines. All other rays move in arcs. The closer light rays pass to the center of the hollow world, the slower they propagate. Any movement slows down in its central part. Thus, the speed of light is not constant. However, this is imperceptible to an observer inside the system. Gravity, according to Teed, was generated by the sun, emitting special rays besides light ones, which were reflected from the Earth's metallic layers. Like in the geocentric system, Earth holds a special position in this world system. In Ptolemy's and medieval cosmology, Earth was central in the universe. In Teed's model, Earth's spherical shape forms the boundary of the visible world. Yet, this raises the question of what lies on the outer side of Earth. Perhaps Earth is infinite after all? When Teed finally awoke, he had one goal in life. He decided to share his revelation, the apocalypse of Cyrus. Overnight, he transformed from a physician into the founder of a new faith, a modern prophet. He adopted a new name, taking the ancient Hebrew version of his name, Koresh. He established a new society, the Koreshan Unity. In 1870, the first meeting of the New Faith supporters took place in New York. He then traveled to Chicago and San Francisco. Although he did not attract large crowds, his sermons and lectures drew enthusiasts who, like him, rejected modern scientific views because they saw Earth as a speck lost in the vast cosmos. An unexpected encounter spurred him to new actions. During a missionary trip to Chicago, he met inventor, publisher, and surveyor Ulysses Grant Morrow. Years of life, 1864 to 1950. They liked each other from their very first conversation. Professor Morrow, though no one can now explain why he held this title, joined the Christian Union. He decided, as any proper scientist would, to conduct an extraordinary experiment and definitively prove Cyrus Sadato's theories. Morrow designed a colossal ruler, capable of mechanically setting a horizontal line anywhere on the globe. This device, literally a leveler, was intended to measure the Earth's surface curvature. Morrow believed this measurement could reveal whether we live on the surface of a convex sphere open to the vast cosmos, or if we are trapped inside a hollow sphere, peering into the enclosed void above, filled with the imaginary reflections of a single light. The leveler consisted of 4 segments, each 3.64 meters long, with crossbars attached at right angles to both ends, allowing the segments to be connected. The position of each segment could be adjusted with millimeter precision. The entire structure, attached to 2 posts, measured 14.56 meters. Holes were dug to install the posts, and the structure was disassembled, moved, and reassembled numerous times. By early May 1897, the structure had been moved 1,045 times, covering a distance of 3.8 kilometers and reaching the sea. What did the experimenters achieve with these measurements? Exactly what they aimed for. The correctness of Cyrus Sadato's theory was confirmed, declared the professor and the preacher in unison. The sea level rises towards the horizon because we live inside a gigantic concave sphere. However, the scientific revolution did not materialize. The scientific community did not believe the 2 eccentric individuals who, without witnesses or opponents, remeasured something and now shook tables with numbers. The psychological interest of all participants in the experiment was undeniable. They all wanted to confirm their teacher's correctness. Strangely, everything was brilliantly confirmed, leading one to ponder whether the entire experiment was staged as a spectacle to demonstrate results needed by the sectarians. The idea of a concave cosmos has not died even today, surviving in the deserted realms of the internet, where its few adherents passionately discuss the true structure of our world, the doctrine of eternal ice. On a summer morning in 1925, all known German and Austrian scientists received identical letters, causing a storm of indignation in laboratories and libraries. The text was an ultimatum. It was time to choose sides, with us or against us. While Hitler cleared politics, Hans Urbiger swept away false sciences. The doctrine of eternal ice was to become a symbol of the German people's renewal. Know this. Join us, or it will be too late. The man who dared threaten scientists was named Hans Urbiger, or Urbiger in another transcription. At 65, his long gray beard made him look like an angry prophet. He had reason to be noisy and furious, as he set out to preach a truth that contradicted all basic principles of astronomy and mathematics. Urbiger, like a madman, decided to discard 1,000 years of scientific history and start anew, with only his name inscribed. He considered objective science a pernicious invention, a totem of decadence. Like Hitler, he believed the most urgent task was to know who desires to know. Only a prophet like him had the right to engage in science, as the power of his enlightenment elevated him to the highest level of consciousness. However, His idea of science was entirely different from what everyone understood. His scientific revelations were accessible only to him, and he knew no doubt. Any slight objection enraged him. "You trust mathematical equations, not me," he thundered. "How long will it take for you to understand that mathematics is a paltry lie?" What truth was revealed to him? What is the doctrine of eternal ice? Austrian engineer Hans Urbiger, 1860 to 1931, announced his doctrine on the eve of the Great War in 1913. His doctrine was as bright and insane as the speech of a madman. According to this teaching, millions of years ago, there was a giant star in the constellation Blue, whose mass exceeded the sun's by millions of times. One day, a huge planet made of water ice with a metallic core in the middle crashed into it. The icy surface of the planet, covered with a powerful crust of slag, did not melt immediately and remained inside the star for a long time. Eventually, all the water ice evaporated, and the star exploded like an overheated steam boiler. The star's fragments scattered across the universe, forming the sparkling Milky Way from its lightest elements. From the remaining frozen water ice, the solar system and the icy Milky Way, located just 3 times farther from the sun than Neptune, were created. The solar system is filled with countless ice particles and hydrogen clouds, which Urbiger called ether, slowing the planet's movements. Eventually, small planets will collide with larger ones, becoming their satellites, and all planets will ultimately approach the sun and evaporate. Initially, there were more than 30 planets. Now, only a few remain. The rings around Saturn are the remnants of Uranus. The outer planets Mars, Jupiter, Saturn, Uranus, and Neptune, named Neptunioids by Urbiger, are essentially water spheres covered with thick layers of ice. The inner planets, or helioids, Venus and Mercury, consist mostly of metals with a thin ice crust. This thin ice forms when interplanetary ice chunks, created by the initial explosion, fall onto the sun. Their fall causes sunspots as water vapors evaporate and freeze upon entering space, forming cirrus clouds observed on Earth. The Earth occupies a central position in the solar system. It is neither covered with a thin ice crust like Venus, nor with kilometer-thick layers of ice like the Moon or Mars. The Moon, once a planet, is now approaching Earth and will inevitably break apart under its own weight, with its fragments destroying everything in their path. Earth's history has witnessed several such catastrophes. The biblical flood occurred when ice debris from the sixth moon melted. Around 12,000 years ago, when Earth captured the current moon, a similar flood wiped out Atlantis. German myths and the apocalypse of St. John preserve the memory of these global catastrophes. One day, after hours of gazing at the moon through a telescope, inspiration struck Urbiger. In an instant, he realized that the moon's glow was due to its ice covering. He believed this discovery would bring him immortal fame. A few nights later, a second revelation came to him in a dream. He saw a silver pendulum swinging uncontrollably, growing larger until it disintegrated. He understood that Newton was wrong. The sun's gravitational force no longer acts beyond 3 times the distance between the sun and Neptune. Based on these revelations, he developed the doctrine of eternal ice. All of existence is an arena of constant struggle between fire and ice, between Neptunism and Plutonism. The solar system emerged from a cosmic collision between a blazing sun and an icy giant. In 1913, Urbiger published his revelations in an almost 800-page tome, Glacial Cosmogony, which he worked on since 1894. From the outset, he considered his teachings infallible, stating unequivocally that what agrees with him is true and what doesn't is false. Initially unnoticed, his volume gained attention after the war. The Society of Eternal Ice and the Herbiger Institute in Vienna emerged, with supporters demanding the abolition of routine astronomy lessons, chanting, "We want Herbiger." Even intellectuals like poet Gottfried Benn were captivated by this catastrophic doctrine. Scientists uniformly rejected his revelations, but he saw this as their loss, believing himself the sole German genius. Herbiger dismissed astronomical evidence as reactionary fabrications. His worldview contradicted celestial mechanics, leading him to declare any alternative calculations as deviations from the true path. He told one opponent bluntly, "You'll either learn to believe in me or become my personal enemy." Herbiger did not live to see the Third Reich, but his teachings inspired the Nazis, who dubbed him the Copernicus of the 20th century. Admirers included Hitler, Himmler, and other notorious leaders. The Society for Ancestral Heritage, established in 1933 to study all aspects of the Nordic race and integrated into the SS in 1937, embraced this doctrine. As the war between the solar Third Reich and the icy Soviet Union loomed, the collapse of the Reich also marked the end of the doctrine of eternal ice. Post-1945, only esoteric enthusiasts showed interest in it. Or even more precisely, amidst the starry sky, the sun and a star inexorably approached each other, like two planes closing in on each other for a collision in a cloudless, starless sky. But the collision did not occur. The most powerful tidal forces at play during the close approach of the two stars prevented a collision, but at what cost? Massive amounts of matter were ripped away from the stars. When this swirling matter eventually calmed and the rogue star retreated into the distance, planets formed from this matter, now surrounding the sun with their colorful family. However, a detailed analysis of Jean's hypothesis revealed its inadequacy. It was rejected. In modern cosmogony, catastrophic hypotheses are not considered. By the 1940s, astronomers returned to the Laplace theory, slightly modified. The initial mass of the protoplanets was refined, and the deficit of angular momentum was explained by the action of magnetic forces. Today, this is the accepted theory of the origin of the solar system. According to current understanding, the gas-dust nebula that gave birth to our and many other planetary systems consisted mainly of hydrogen and helium, formed during the Big Bang. Less than 1% consisted of heavier elements and compounds, like water, ammonia, carbon monoxide, and carbon dioxide. Separate parts of this nebula contracted and condensed. This could have been triggered by supernova explosions nearby. Shock waves from these explosions permeated the nebula, causing the formation of clumps. These became the seeds of perhaps several hundred, if not thousands of stars. The star cluster that over hundreds of millions of years dispersed into many single and binary stars. One of these stars was the Sun, surrounded by its gas and dust cloud. Millions of years passed until planets appeared around the Sun. The protoplanetary disk from which they arose extended billions of kilometers. Its mass could be from 1 to 10% of the star's mass. According to astronomers, the formation of the solar system was completed about 4.568 billion years ago, with a calculation error of 2 million years. This conclusion was reached by studying certain types of meteorites whose composition is close to the protoplanetary disk. The crucial factor in the process of planet formation was their distance from the sun refractory substances, and compounds condensed first in its vicinity, while solar wind blew volatile substances to the periphery of the solar system, where gas giants formed. Currently, rocky spheres of Earth-like planets are located near the Sun. From the remaining material not captured by the planets, small celestial bodies, comets, and asteroids formed, which have changed little since the formation of the solar system. Therefore, their study can clarify many still unclear aspects of this theory. Searches for Transpluto and Kuiper belt abundance. In 1846, the planet Neptune was discovered at the tip of a pen. It was located beyond the orbit of Uranus. Its orbital path seemed to deviate slightly from the calculated path. These deviations could only be caused by the gravitational pull of a planet X, as dubbed by one of its enthusiastic seekers, the American astronomer Percival Lowell, 1855 to 1916. From 1905 until his death, he methodically searched for this object, understanding that the distant planet should have low brightness. Lowell ordered a special photographic telescope, the astrograph, but this years-long work did not yield the desired result. However, his laboratory staff continued the search. 14 years after his death, on February 18, 1930, his young colleague Clyde William Tombaugh, 1906 to 1997, discovered the ninth planet. It appeared as a 15th magnitude star in the constellation Gemini. For several months before this, he had photographed sections of the sky each night through a telescope, then repeated the process a few nights later. By day, he examined hundreds of stars on the developed photographic plates, looking for a shifted point, a new planet. The prolonged search was due to the planet's small size and inaccurate predictions. The new celestial body was found 500 million kilometers closer to the Sun than Lowell had thought, and its orbit was significantly inclined compared to other planets. Later, the long-awaited newcomer was named Pluto, the Greek god of the underworld, ruling the planet of eternal twilight. But something was amiss even in Pluto's realm. The distant parts of the solar system still held many mysteries. As it soon became clear, Pluto was too small to cause the observed deviations in Neptune's motion. So, might there be other planets beyond Pluto's orbit, similar to it, or perhaps a 10th planet? At that time, the method of discovering objects by calculation was popular among astronomers. They calculated the possible mass of Transpluto, the unknown planet, that could account for the peculiar motions of Neptune and Uranus, although its existence could not be proven. It was likely that it seldom came close to other planets, as its orbit was extraordinarily elongated, taking 800 years to complete one revolution. Currently, it has moved away from other planets and does not affect their behavior. Finding it is extremely difficult, hidden among countless stars, and would take a lot of time. Astrologers, more inclined to accept wishes as reality, even gave it a name, Proserpina. That's what the Romans called the goddess of the underworld. Clyde Tombaugh, fully convinced that the solar system didn't end with Pluto, continued searching for the 10th planet for 13 years after his discovery. Over those years, he examined 45 million suspicious objects, but they all turned out to be stars. It seemed Pluto's orbit should be considered the boundary of the solar system. However, his colleagues disagreed. From 1957, American astronomer Henry Leicheglas, 1910 to 2007, systematically photographed sections of the sky where Transpluto might be found. This work continued for 18 years. Only in the 1980s, after the Voyager 2 space probe flight, was the mass of the distant giant planets refined. It turned out that previous calculations suffered from inaccuracies. When new mass values for Uranus and Neptune were substituted into the equations describing their orbits, all deviations disappeared. It became clear that beyond Pluto, only comets and asteroids could be found. Scientists had already succeeded in expanding the solar system with new planets through careful calculations. Now, they had to use these calculations to delineate the possible planets. However, observations of the distant regions of the solar system continued, especially since Pluto remained an entirely mysterious planet, known even less than distant stars. Soon, it became clear that beyond Neptune's orbit, countless small planets existed. The first of them, besides Pluto and its satellite Charon, 1992 QB1, was discovered in August 1992. Its diameter was estimated at 200 kilometers. It moved almost in a circular orbit 50 astronomical units from the Sun. In March and September 1993, several more asteroids were found on the outskirts of the solar system. In the following years, discoveries became frequent. Pluto turned out to be just the brightest representative of a vast family of small planets, forming the second asteroid belt in the solar system, the Kuiper Belt. Today, there are already about 1,500 known objects in this cluster, a flat ring of enormous width. It begins just beyond Neptune's orbit, 30 astronomical units from the Sun, and possibly ends at a distance of 150 astronomical units from the Sun. This belt is also thought to be the source of comets with short and medium orbital periods. When it was announced in 2005 that Eris, a planet similar in size to Pluto, had been discovered, its diameter is only 50 to 60 kilometers smaller than Pluto's, astronomers were concerned that the number of planets in the solar system would significantly increase. They decided to separate the wheat from the chaff and remove Pluto and similar objects from the list of main planets in the solar system, leaving only 8. Even if the mysterious 9th planet, currently being sought by astronomers, is found, it will be given a special status, such as being classified as a major peripheral object of the solar system KPAS. In principle, astronomers do not rule out the existence of an unknown planet at the periphery of the solar system, a ghost planet or a silent planet. It does not disrupt the movements of known asteroids and has remained unnoticed by telescopes and the few probes that have reached the edge of our cosmic neighborhood. It likely moves in a highly elongated orbit at a great distance from the Sun, with its orbital plane strongly inclined to the plane of the ecliptic. However, it is unlikely that a brown dwarf or an unseen satellite of the Sun, a dwarf star nemesis, hides in the darkness of the outskirts. They would likely have been detected by our telescopes. Perhaps this planet X should be called not Transpluto, but Trans-Kuiper, since calculations show it should be beyond the Kuiper Belt. In 2016, American astronomers Konstantin Batygin and Michael Brown reported in the pages of Astronomical Journal that the mass of this unknown planet should exceed Earth's by at least 10 times, and its orbital period around the Sun could be 20,000 years. It is located 600 times farther from the Sun than Earth. These are astronomical scales, indeed. Light takes about 3.5 days to cover this distance. But the story of this planet is entirely different, a myth or fact science has yet to determine. Astronomy and the age-old power of astrology. The main objections against astrology, one of the most popular pseudosciences, are well-known and convincing. Statistics speak firmly against it. According to numerous studies conducted in various countries, the position of the Sun in the zodiac at birth does not influence personality development. Here is one of many examples cited by Russian astronomer Serdan. French statistician Michel Dequelin studied archival data containing the date, time, and place of birth of 41,000 European residents. Among them were 16,000 notable scientists, artists, writers, athletes, and so on, as well as 25,000 ordinary people. Dequelin correlated the positions of planets and constellations at birth with personality type and occupation. He concluded that there is no connection between a person's character and activities on the one hand, and their zodiac sign, the positions of planets and houses, and their mutual aspects at birth on the other. However, until the 20th century, The primary task of astrology was not to create horoscopes for ordinary people, but to predict future events under the banner of celestial omens. Astrologers advised kings and generals on the best times to declare war, launch a campaign, or make peace, based on their observations of the stars and planets. Astrology emerged in ancient times when the blow of fate or the wrath of almighty gods could strike people from anywhere, leaving only speculation as to when and where it would occur. If gods descended to humans from the heavens in nearly all religions and cultures, perhaps before making their decisions, they illuminated the celestial lights. Thus, the future could be read in the light of stars and the gleam of planets. The roots of modern Western astrology trace back to the pre-Christian era, Babylon, Mesopotamia, and ancient Egypt, likely extending further to where written records have not preserved this knowledge. In ancient times, astronomy, a noble practice of interpreting the future, always had its pale shadow, astronomy. Like a boy grinding pigments for a Renaissance painter, astronomical work was auxiliary, observing stars and planets, calculating their movements. Only astrology dared to interpret what was seen, confidently relating one celestial event to another terrestrial event. Their arbitrary coincidences became laws. From a scientific perspective, astrology in the ancient world was not superstition, but proto-science, an emerging field. American researcher Lawrence Jaron noted in his book Astrology and Modern Sciences, a critical analysis that seeking patterns in the world around us and describing them is a scientific approach. No wonder German philosopher Ernst Cassirer noted nearly a century ago that astrology fundamentally uses scientific forms of thinking. Causes are analyzed, conclusions are drawn, inevitably following initial conditions, and final results are deduced. Astrology was based on the ancient belief that celestial bodies directly influence earthly events. To evaluate this influence, astrologers used mathematical methods to identify patterns in celestial phenomena. Since the timing of events played a crucial role in predictions, astrologers compiled detailed tables through long-term observations, indicating the positions of major celestial bodies at specific moments. Using geometry, they plotted planetary orbits, laying the foundations for future science, astronomy. The history of astrology in Europe was variable. The ancient Greeks borrowed zodiac signs and horoscope construction systems from the Babylonians. In the 3rd and 2nd centuries BC, the Emerald Tablet, attributed to Hermes Trismegistus, appeared. It stated, "That which is below is like that which is above, and that which is above is like that which is below." The triumph of Christianity in the Roman Empire initially led to the prohibition of astrology. The Council of Laodicea in 364 AD decreed that it was not fitting for clergymen or laypersons to be sorcerers, enchanters, diviners, or astrologers. The Church persecuted astrologers as it did witches, healers, and mimes, all undermining faith in God. However, astrology survived these persecutions. Aided by its dual nature and proximity to astronomy, the science of stars and planets. In the 8th century, learned astrology and astronomy flourished in the Byzantine Empire. In the late Middle Ages, astronomy infiltrated schools. By the 12th century, general schools in Europe were accessible to more than just monks, teaching the 7 liberal arts divided into the trivium and quadrivium. The trivium included grammar, rhetoric, and dialectic, and the quadrivium consisted of arithmetic, astronomy, music, and geometry. However, geometry was actually geography, and astronomy was astrology. During the Renaissance, astrology was popular throughout Europe. No wonder, in Schiller's famous drama, The Death of Wallenstein, dedicated to the events of the 30 Years' War, 1618 to 1648, the main character, General Albrecht Wallenstein, eagerly gazes at a large blackboard where the astrologer has drawn the positions of the planets. It predicts an unprecedented triumph for him. The fortunate alignment of planets, a great triumph in time. The destructive, treacherous Mars is caught between two favorable luminaries, Venus and Jupiter. They will subdue the harmful enemy. However, from the title of the play, it's clear how cruelly the stars mock. Instead of triumph, Wallenstein meets his death. The spirit of the New Age, to which Schiller belonged, the Age of Enlightenment, mocking and disdainful, rejected this ancient dynamic as a science. No physical connection between the movement of celestial bodies and earthly events was identified. Interest in astrology reawakened only at the turn of the 20th century, when theosophy, occultism, and spiritualism became fashionable. Astrology found its place again. It experienced another surge of popularity in the 1960s. Horoscopes then, as now, were the most successful, as among the random advice and predictions, there would occasionally be accurate ones. Scientists call it a coincidence, but professional astrologers pride themselves on another success. Who is right? Let's cite another example from Cerdin's book, Expanding the Boundaries of the Universe. In one of his works, Kepler warned researchers not to throw out the baby with the bathwater when dismissing astrological superstitions. Analysis of astrology's predictive capabilities continues to this day. So far, no baby has been found in this bath, only murky water. As is well known, the famous astronomer Kepler drew up horoscopes. However, here's how he expressed his view of classical astrology. An astrologer who predicts something solely based on the heavens, without considering the character, soul, intelligence, strength, and appearance of the person he predicts for, is on the wrong path and gives advice based on luck. So, is it clear whether astrology is a science? Geocentric system of the universe. This system of the universe seemed to illustrate Protagoras' famous phrase, "Man is the measure of all things." At the center of the universe here rested or revolved around its axis, the Earth, meaning man was at the center of the universe. The sun, moon, and planets revolved around the Earth. This seemed an unshakable truth, as people since ancient times had seen numerous stationary stars in the night sky, leading to the idea that Earth was also motionless. In this world, embraced by blissful peace, only the sun, moon, and planets moved. With the development of mathematics, scientists couldn't help but believe that these movements could be described to predict the positions of celestial bodies. In its ideal form, according to the ancient Greek scientist Eudoxus of Cnidus, 390 to 338 BC, the movement of celestial bodies was reduced to the sum of uniform rotations of a series of spheres, on whose surfaces the planets were located. These spheres, known as homocentric spheres, revolved around a common center where Earth resided. However, the apparent simplicity of the scheme was very deceptive. Ancient Greek astronomers had long noticed some peculiarities in the behavior of celestial bodies. They observed that the sun moved irregularly along the ecliptic, the moon traced a wavy line in the sky, and planets, moving among the stars, described inexplicable loops. Striving for accuracy and harmony simultaneously, Eudoxus, to obtain a qualitatively accurate picture of celestial movements, devised a complex combination of several spheres for each planet. Here is how he described the moon's movement, using 3 spheres. The first sphere revolved around the central axis, completing 1 rotation per day. The second sphere made a rotation relative to the previous one every 18.6 years. Finally, the third sphere attached to it made 1 rotation every 27.3 days. The moon was located at the equator of this sphere. The combination of rotations occurring in different planes resulted in a pattern matching the observations. From a kinematic perspective, it makes no difference whether Earth revolves around the Sun or the Sun around Earth. The distance between them remains unchanged, wrote Russian science historian Zhitomirsky, contemporary of Eudoxus, Heraclitus of Pontus, 390 to 322 BC, based on the fact that Mercury and Venus never stray farther from the Sun than a certain arc, suggested that they revolve around the Sun. This idea became widely accepted in Hellenistic astronomy. However, the Sun itself, like the Moon and stars, revolved around Earth. Thus, Heraclitus introduced the concept of epicyclic movement in astronomy. A celestial body following this pattern revolved around a center, which in turn revolved around Earth. One of the greatest philosophers of ancient Greece, Aristotle, 384 to 322 BC, theoretically substantiated what seemed obvious, that Earth resides at the center of the world. In his book on the heavens, he wrote that Earth must necessarily be at the center and immobile because objects thrown upwards fall back to the same place, even if projected to an infinitely great distance. From this, it is clear that Earth neither moves nor lies outside the center of the universe. Without a center like Earth, the fall of objects would continue forever. According to Aristotle, the shape of Earth must necessarily be spherical, as each of its parts is weight and tends downward until it reaches the center. This system of the world was called the Geocentric system, from the Greek geo meaning earth. It explained many, but not all, observed celestial phenomena. Apollonius of Perga, 262 to 190 BC, and Hipparchus, 190 to 120 BC, improved Eudoxus's theory, but to explain the observed planetary movements, they had to alter the geometry of the universe. The great geometer Apollonius was the first to introduce, instead of cumbersome spheres, an ingenious system of interconnected circles, epicycles, and deferents, later firmly associated with the name Claudius Ptolemy. Hipparchus proposed that the Sun revolved around the Earth uniformly and moved in a circle, but the Earth was offset from the center of this circle. This explained the varying lengths of the seasons. Through observations, Hipparchus established that spring lasts about 94.5 days, summer 92.5 days, autumn 88 days, and winter around 90 days. He called the orbit in which the Sun moved the eccentric, and the distance between the two centers the eccentricity. He adjusted its value to match his measurements. The issue with planets was more complicated. Their observed movements were too complex to describe using simple geometric models, a problem Hipparchus could not solve. An ideal model, by ancient standards, was created almost 300 years later by the last of the great Greek scientists, Claudius Ptolemy, 100 to 160 AD. Ptolemy replaced Hipparchus' simple model, where each celestial body made a single circular motion around the center of the planetary system, with a more complex and accurate scheme involving several circular motions. This allowed him to explain the looping movements of the planets. Additionally, Ptolemy skillfully modified the system of epicycles and deferents so that planetary movements could now be predicted years in advance, which was all that was required of astronomy at the time. In the simplest case, according to Ptolemy, a planet moves along an epicycle, the center of which moves along another circle, the deferent around a stationary Earth. To fit the theory to observations, additional epicycles had to be introduced. According to Russian astronomer Brahe, Ptolemy managed to match the sizes and rotation speeds of all the wheels of his universe to achieve highly accurate descriptions of planetary movements. Ptolemy's system became the pinnacle of ancient astronomy, producing results that matched observations. It could be continuously refined and complicated, achieving the highest accuracy. However, this complexity eventually led to its downfall. Over 1,500 years, astronomers refined Ptolemy's system. By the early 16th century, describing the movements of the Sun, Moon, and the 5 known planets required 77 circles, deferents, and epicycles. Many astronomers began to see this theory as overly complex. This view was shared by Polish priest and astronomer Nicholas Copernicus, 1473 to 1543. He sought to make Ptolemy's model more elegant and straightforward. Copernicus admitted he took on the task of reading all the philosophers' books he could find to discover if anyone had ever suggested movements of celestial spheres different from those taught in mathematical schools. Thus, he found in ancient texts the thesis of Earth's motion. Following this idea, considering Earth as one of the planets rotating on its axis and moving along an epicycle, with the Sun at the center of the universe, the system became much simpler. In this heliocentric system, the number of circles was reduced to 34. Copernicus' system, presented in his main book on the revolutions of the celestial spheres, proved convenient for calculations. It allowed the explanation of the Sun's apparent motion across the sky, although in its initial form, it was not fundamentally more accurate than Ptolemy's system. However, the shift to the heliocentric system, where Earth orbits the Sun, fundamentally altered our understanding of the universe, leading to subsequent discoveries by Galileo, Kepler, and Newton. Thus, Copernicus's teachings laid the foundation for all modern science. In search of counter-Earth, for over 2 decades since the first exoplanet discovery, astronomers have been searching for a second Earth with conditions similar to our own. Counter-Earth Antichthon, or anti-Earth, is also considered Earth's twin, but it was supposed to be located not in distant star systems, but much closer. Hypothetically, it orbited the Sun along the same path as Earth, moving synchronously, and was thus perpetually hidden behind the Sun. This hypothetical planet was, for ancient astronomers, a nearby but unreachable curiosity. Located just 2 astronomical units away, 1 diameter of Earth orbit, it remained unobservable from Earth. It was easier for ground-based telescopes to peer into other galaxies than to notice this elusive planet. With the advent of space technology, it became clear there was no counter-Earth. However, the concept persisted for a long time. First mentioned in the 5th century BC, its description was left by the ancient Greek philosopher Philolaus, 470 to 388 BC. Philolaus of Croton was a follower of the mathematician Pythagoras, whose school or sect attributed real power to numbers. By the late 5th century, Pythagorean mystics had incited hatred among citizens and were harshly suppressed. According to legend, Philolaus was one of the 2 survivors. Ancient authors wrote that Philolaus was the first Pythagorean to publicize their teachings. He wrote a book on nature, which has survived only in fragments, discussing the structure of the universe. Byzantine writer John Stobaeus, in the 5th century AD, described this fantastical worldview. Philolaus places fire in the center, calling it the hearth of the universe, the home of Zeus, the mother of gods. He posits another fire, the highest and most encompassing. Around the central fire, 10 divine bodies, heaven and planets, circle in a chorus, followed by the sun, under it the moon, then earth, then counter-earth, and finally the fire. According to another version, Earth was not a single body, but consisted of 2 independent hemispheres, Earth and counter-Earth, separated by an equatorial gap, through which the sacred flame's heat reached the sky. In this system, counter-Earth, orbiting synchronously with Earth, remained invisible, hidden behind Earth itself. Modern researchers note that Philolaus' hypothesis would be easily testable today by sending an expedition a quarter of Earth's circumference. However, as Zito Riley commented, for that era, such advice would be as feasible as proposing that today's astronomers fly to the galaxy's center to check for a black hole. It was also impossible to send an expedition because Philolaus, unlike other Greek astronomers, considered the Earth to be a flat disk. We live on the side of Earth, that is always turned away from the central fire and faces the sun and other planets. Therefore, life is possible here. The terrible fire does not burn the world to ashes. Only particles of it illuminate and warm the inhabited part of Earth, as the sun is glassy and reflects the fire in space. The other side of the Earth, facing counter-Earth and the central fire, is uninhabitable. We do not know how accurately John Stobaeus conveyed this mystical doctrine that arose 1,000 years before him. For instance, in meteorology, Aristotle commented on the Pythagorean astronomical theory and explained the appearance of counter-Earth. Since they considered numbers to be the principle of all nature, they applied numerical relationships to define the heavens and nature. Where anything did not fit, they tried to add what was missing to make it align. For example, since the number 10 seemed the most perfect, encompassing the entire nature of numbers, they said there must be 10 moving spheres in the heavens. As we can see only 9 spheres, they invented the 10th one, counter-Earth. Regarding the 9 mentioned spheres, they included the sphere of fixed stars, the spheres of the 7 planets, Saturn, Jupiter, Mars, Venus, Mercury, Sun, and Moon, and the sphere of the Earth. But did counter-Earth appear solely for the harmony of numbers? In the Pythagorean cosmos, it played a crucial role. All celestial bodies were considered ethereal, meaning they were light and had very little mass. Earth, on the other hand, was a massive solid clump. It wouldn't have been an issue if Philaeus, like other Greek scientists, had placed it at the center of the universe, but it orbited around the central fire. If a massive Earth was on the periphery, the universe's center might not coincide with its center of gravity. The harmony of celestial spheres would be disrupted. Philaeus, or another Pythagorean, whose teachings he relayed, balanced the Earth by placing a planet as massive as ours on the opposite side of the central fire. In Aristotle's world system, such problems could not arise. Earth, with its perfect spherical shape, became immobile at the center of the universe for 1,500 years. All other planets, the sun and stars surrounded it. In this majestic cosmic picture drawn above us, there was no place for counter-Earth. From the mid-16th century, during the time of Nicholas Copernicus, Earth left the universe's center, yielding it to the sun for several centuries. In this renewed world system, unexpectedly, there was space for Earth's counterpart. French mathematician Joseph-Louis Lagrange, 1736 to 1813, analyzing the motion of celestial bodies, discovered a specific point behind the sun that was special. Today, we know of 5 so-called Lagrange points. Any celestial body in one of these points can remain there indefinitely because the forces acting on it, including the sun's and Earth's gravity, balance out at these points. Only an external influence can dislodge an object from a Lagrange point. Here is a diagram of these Lagrange points. L1, between Earth and the Sun. L2, on the opposite side of Earth from the Sun. L3, on the opposite side of the Sun from Earth. L4 and L5 form an equilateral triangle with Earth and the Sun, leading and trailing Earth orbit, respectively. These points are interesting because objects placed at these points can theoretically remain in a stable position relative to Earth and Sun, making them ideal for space missions and observations. 2 of the Lagrange points are located close to Earth, one between Earth and the Sun and the other on the opposite side of Earth. Another 2 are situated along Earth's orbit, ahead of and behind Earth, deviating from it by 60 degrees. The last of these points, officially named L3, is where counter-Earth would theoretically lie, on the opposite side of the Sun along Earth's orbit. In theory, an unknown planet could be located there. But let's assume the space age hasn't begun yet. Practically, this is impossible for the following reason. Lagrange's calculations were based on the three-body problem, ignoring the influence of all other planets besides Earth. However, they also exert some gravitational effects on a planet in the L3 point. Calculations show that in just a few million years, gravitational perturbations would dislodge counter-Earth from the Lagrange point, causing it to collide with Earth. Today, scientists are confident that if counter-Earth had formed at the same time as Earth, approximately 4.5 billion years ago, both planets would have collided shortly after the solar system's formation. Earth was spared because the probability of two identical planets forming at the same distance from the Sun is very low. In search of the seventh and eighth heavens, the world of medieval Europe arose from the ruins of the Roman Empire. It is not surprising that its understanding of the cosmos was inherited from antiquity, primarily based on the writings of Plato. Especially important for medieval science was his dialogue Timaeus, which is the only systematic outline of Plato's cosmology. Written several centuries before the triumph of Christianity, it is considered an apology for the creator God. He constructed the cosmos as a unified whole, made of integral parts, perfect and free from decay and disease. He rounded the cosmos to the state of a sphere through rotation, with its surface uniformly distant from the center, providing the universe with the most perfect shape. In the 12th and 13th centuries, works of Aristotle and Ptolemy reached Western Europe from Byzantium and Arab countries. The fortunate rediscovery of Aristotle's works was pivotal for Europe, as they presented a complete rational system explaining the entire world based on natural causes, highlighted by Australian historian of science Alistair Crombie in his book From Augustine to Galileo, The Emancipation of Natural Sciences. This approach resonated with the spirit of the High Middle Ages, which saw a growing drive to rationalize all aspects of life, including faith. The most perceptive realized that Christianity initially sought, but could not find, a philosophical system that could harmoniously blend with Christian doctrine, promising to become a rational support for dogma and a weapon for apologetic. This was noted by Dutch historian of science Edward Ditch de Ruys in his book, The Mechanization of the World Picture. The translated works of Aristotle and Ptolemy ignited vigorous debates involving the leading intellectuals of the High Middle Ages: John of Sacrobosco, Roger Bacon, Albert the Great, Thomas Aquinas, Robert Grosseteste. These discussions shaped a rational understanding of the surrounding world and the cosmos. What was this cosmos like? The medieval cosmos was divided into the sublunary world and the celestial spheres rising above it. The Earth remained motionless at the center of the universe, surrounded by a system of concentric celestial spheres. At the highest and outermost sphere, beyond human sight, resided God. The celestial spheres, unaffected by change, represented perfection. The sublunary world, the earthly realm, was shaken by changes and metamorphoses. Everything here was transient and unstable, marred by weaknesses and flaws. In the early Middle Ages, the world system was clear. Above the Earth, spheres of the Moon, Sun, planets, Venus, Mercury, Mars, Jupiter, and Saturn, and fixed stars were sequentially arranged. The planetary spheres glided perfectly relative to one another. They were absolutely transparent, made of quintessence or ether. Each planet was attached to its sphere. It was commonly believed that stars and planets were made of the same ether as the celestial spheres, visible only because the ether's density in them was extraordinarily high, reflecting sunlight or glowing themselves. These celestial bodies were different faces of eternity, indestructible, their only change being uniform circular motion, which could last indefinitely. Medieval scholars usually added two more spheres to this ancient scheme, revealed in the sacred book of the Bible. In Genesis, it says, "And God created the firmament, and divided the waters which were under the firmament from the waters which were above the firmament. It was believed that the concentration of water above the firmament formed the crystalline or crystal sphere, thought to be the prime mover of all other spheres below it. Often, the blessed souls of virtuous people and saints were placed there. Finally, there was the Empyrean, the kingdom of God and heavenly beings, angels, archangels, cherubim, seraphim. The great Portuguese poet Luís de Camões praised the Empyrean in his epic poem, The Lusíads. And the first orbit, in its radiant revolution, encompasses the lesser spheres which, with fiery fervor, set limits to sight and mind. That is the Empyrean, the abode of the blessed, the divine domain of lofty souls. There they enjoy eternal happiness, unknown in this transient world. Just as if hundreds of people suddenly saw the same dream and, upon waking, began to write it down from different starting points and then, upon comparison, found they had all written about different things. Medieval authors left us very diverse descriptions of the cosmos, derived from their readings of ancient authors and their own reflections and visions. For example, the Anglo-Saxon chronicler Bede the Venerable, 672 to 735, wrote only about 7 celestial spheres, following the Bible rather than ancient models. However, French historian Jacques Le Goff noted that in Bede's cosmology, Greek heritage is evident even in terminology. Directly above the earth extended the sphere of air, followed by the sphere of ether, then the sphere containing all the planets, which Bede called Olympus because the planets were named after Greek gods. The celestial fire blazed above these closer heavens, sometimes reminding people of its presence with phenomena like the aurora borealis, comets, or meteors. Above this sphere extended the firmament of fixed stars. Above lay the heaven of angels, with the 7th heaven, the abode of the Holy Trinity, sealing the universe. Bede's cosmology is interesting because it shows how an educated person of the 8th century imagined the universe. This concept's Christianization continued, culminating in its simplification, as evidenced by the 12th century thinker Honorius of Autun, who distinguished only 3 realms: the corporeal heaven that we see, the spiritual heaven inhabited by spiritual substances, i.e. angels, and the intellectual heaven where the blessed contemplate the Holy Trinity's face. Other authors, envisioning the heavens, avoided this minimalism. The British mathematician and astronomer John of Sacrobosco, 1195 to 1256, authored the 1230 treatise De Sphera, which remained a standard astronomy textbook until the 17th century, preferred the order of spheres followed by Aristotle. After the moon, he placed Mercury and Venus, followed by the sun and the remaining planets. Almost all depictions of celestial spheres from the Renaissance and modern times follow this pattern. Thomas Aquinas, 1225 to 1274, referencing ancient authority, wrote, "Pythagoras says there are 10 spheres moving in the heavens, of which only 9 are visible from Earth. They are understood through the movement of the 7 planets, the 8th through the movement of the immutable stars, and the 9th through the phenomenon of day, which is the prime mover." Dante Alighieri, 1265 to 1321, built his cosmos with 9 heavens. He combined the crystalline heaven and the heaven of the prime mover into one, not considering the Empyrean a separate heaven. If we now consider how medieval scholars envision the space between Earth and the moon in modern terms, we find 4 invisible spheres. These consisted of the 4 ancient elements: air, fire, earth, and water, arranged by their assigned weight. Closest to the center was Earth, surrounded by water, then air, and finally, up to the moon's sphere, celestial fire. It's essential to clarify that the Earth's sphere should not be equated with the globe it surrounded. It consisted simply of the element called Earth. Medieval theologians saw it as an illustration of the biblical verse about the firmament between the waters, which God called heaven. In the late 16th century, Italian philosopher and astronomer Giordano Bruno, 1548 to 1600, was the first to publicly speak of the imperfections of the celestial spheres. Almost all astronomers before him, including Copernicus and Kepler, believed the cosmos was limited by the sphere of fixed stars. Bruno, however, proclaimed that the universe is infinite, and all stars visible to us are like our sun, only very distant. Planets orbit around them, inhabited by intelligent beings that may not resemble us. 1.5 centuries before Bruno, Cardinal Nicholas of Cusa, 1401 to 1464, a close advisor to Pope Pius II, also made bold speculations. He claimed that the universe had no bounds and was infinite. The machinery of the world has, so to speak, its center everywhere and its circumference nowhere, because God is the circumference and the center, since he is everywhere and nowhere. Now, with Bruno's declarations, the celestial spheres finally collapse, releasing countless stars into the infinite expanse. In this universal catastrophe, the very destroyer of medieval cosmology perished. By then, science and theological dogma had completely diverged. Bruno did not face a cardinal's office but the stake. For his sacrilegious speeches and bold exposure of myths, he was burned by the Inquisition. This execution occurred during the times of Cervantes and Shakespeare, Kepler, and Galileo. The system of Tycho Brahe. In 1588, the famous Danish astronomer Tycho Brahe, 1546 to 1601, published a book titled On Recent Phenomena in the Celestial World. Based on his astronomical observations, he sought to reconcile the irreconcilable, the old, rejected doctrine, and the new one that had rejected it. He aimed to combine the world system considered infallible for 1,500 years with the one that, for half a century, had been rejected by church authorities and many scholars, and was created in opposition to the first. Thus, Tycho Brahe decided to take the best from Aristotle's physics, Ptolemy's geocentric system, and Copernicus's heliocentric system, which moved Earth and set it orbiting the sun. This story began in November 1577, when a bright comet appeared in the sky. Comets had long been considered harbingers of disaster, with their devilish glow heralding war or plague. For 3 months, its deceptive light burned. These months were joyful for Brahe, who regularly observed the comet. Aristotle once claimed that comets were merely atmospheric phenomena. The lunar world was inaccessible to them. It was eternal and unchanging, a belief still held. However, Brahe's and other astronomers' observations indicated that this comet was 3 times farther than the moon, moving as if piercing the celestial vault. Its path crossed the celestial spheres, along with which, as Aristotle believed, the planets moved. So, did these spheres not exist? Brahe began writing a book about comets, but like a ship returning to take on board an important passenger, his book on recent celestial phenomena suddenly included a new world system he presented. Here is how he explained its necessary emergence. I believe that the old Ptolemaic arrangement of celestial spheres was insufficiently elegant, and that the assumption of such a large number of epicycles to explain the visible movements of planets relative to the sun should be considered excessive. At the same time, I believe that the recent innovation of the great Copernicus, reminiscent of Aristarchus of Samos, very subtly eliminates those places that are excessive and inconsistent with Ptolemy's system, without violating mathematical principles. However, Earth's body is large, sluggish, and unsuitable for movement. I, without any doubt, adhere to the opinion that Earth, which we inhabit, occupies the center of the universe. in line with the common opinion of ancient astronomers and natural philosophers, as testified above by Holy Scripture, and does not revolve in an annual orbit, as Copernicus desired. So, how did he manage to combine the irreconcilable ideas, clashing as fiercely as dualists? To reconcile the conflicting astronomical models of his time, Tycho Brahe compromised by creating a hybrid system that combined aspects of both the Ptolemaic and Copernican systems. Brahe was not only a great astronomer, but also a brilliant constructor and mechanic, designing and building his instruments to achieve the highest accuracy in measurements. He increased the size of his instruments and developed new observation methods, such as a special sighting mechanism for the armillary sphere to minimize errors. His confidence in the precision of his measurements led him to question why he could not observe the annual parallax of stars if Earth moved as Copernicus claimed. This doubt led him to develop an alternative system that was kinematically equivalent to the heliocentric model, but avoided its perceived flaws. Brahe suggested that all planets, except Earth, orbited the Sun, which in turn orbited Earth. This model, known as the Tychonic system, explained the peculiarities of planetary trajectories and even predicted the phases of Venus, which were confirmed later with the invention of the telescope. Brahe's system had the computational advantages of Copernicus's system, but avoided theological condemnation. This compromise allowed Brahe to preserve elements of the geocentric model while incorporating the best aspects of the heliocentric model, leading to a more elegant and coherent understanding of celestial phenomena. His innovative approach paved the way for future discoveries and set the stage for the scientific revolution that followed. Brahe was proud of his system of the world, but it did not play a significant role in the history of astronomy, although it did pique the interest of his contemporaries. There are two known instances where other astronomers tried to pass it off as their own discovery. Among its few supporters was the Italian astronomer Giovanni Battista Riccioli, 1598 to 1671, author of the book New Almagest, which was a compendium of astronomical knowledge of that time. However, Riccioli modified the geoheliocentric system of the world, as it was called, of Tycho Brahe. He further limited the power of the Sun, making Jupiter and Saturn also revolve around the Earth. However, this innovation did not help. Brahe's system was rejected by most scientists in the 17th century as unjustifiably and artificially complicated compared to Copernicus's system, which ultimately prevailed. On the magnetic force, at the beginning of the 17th century, it became clear that a strict mathematical order reigned in the solar system. Each planet moves in an ellipse resembling an elongated circle with two foci. The Sun is constantly located in one of them, causing the planet to either approach or move away from it. Consequently, the planet's speed changes. It accelerates when approaching the Sun and slows down when moving away. The farther the orbit is from the Sun, the slower the planet moves along it. But what maintained this order in the heavens? In Aristotle's classical celestial mechanics, the starry sphere stretched over the earthly world possessed the prime motion, which descended to the lower-lying celestial spheres to the nearest planets, including the Moon. The creator of the new celestial mechanics was the German scientist Johannes Kepler, 1571 to 1630, the imperial mathematician for Holy Roman Emperor Rudolph II. After the death of Danish astronomer Tycho Brahe, Kepler acquired a large archive of Brahe's astronomical observations. Based on Brahe's records, Kepler derived the law of planetary motion in 1601, known as the law of areas. Over equal intervals of time, a planet sweeps out equal areas of its orbit sectors. Now known as Kepler's second law, it states that a planet's radius vector describes equal areas in equal intervals of time. In 1605, Kepler formulated another law. Each planet orbits in an ellipse, with the Sun located in one of its foci. This later became known as his first law. In 1609, in Heidelberg, Kepler published New Astronomy, where he presented both laws. The theory of planetary motion became Kepler's greatest achievement. The full title of his famous book is New Astronomy, Causally Determined, or the Physics of the Heavens, presented in studies of the motion of the star Mars, based on the observations of the nobleman Tycho Brahe. This lengthy title is no accident, as Kepler aimed not only to describe the visible, but also to understand the causes of everything happening in the heavens. Unlike Aristotle, he believed that the sun predetermined planetary motion by rotating and dragging other planets along with it. What force did they obey? From a young age, we learned that planets orbit the sun due to the force of gravity. The credit for discovering this law goes to Isaac Newton. However, several decades before Newton, Johannes Kepler also pondered planetary motion and was convinced that some invisible force emanated from the sun, to which all planets adhered. Perhaps, he thought, it was the same force that caused iron filings to align with a magnet. In the 17th century, interest in the mysterious magnetic force grew steadily. In 1600, the English physicist William Gilbert published a work on magnets, magnetic bodies, and Earth as a giant magnet, summarizing all observations and research accumulated over the previous centuries. Building on these facts, René Descartes, in his Principles of Philosophy, 1644, proposed the existence of a special magnetic substance from which many observable phenomena stemmed. Descartes wrote this after Kepler had already attributed the greatest celestial phenomenon, the movement of planets in their orbits, to something similar to magnetism. It's worth noting that Kepler was an avid reader of Gilbert's book, and the described action of magnets reminded him of celestial events, providing a key to understanding them. There is a divine force, proclaimed Kepler in his book Harmonics Mundi, Harmony of the World, published in 1619. It is akin to a magnetic force, the mover soul. It emanates from the sun like rays and affects the souls of celestial bodies, compelling them to move in specific orbits. The sun literally imparts this force to the planets orbiting around it, similar to the widely accepted theory of impetus at the time, where any mover, e.g., a foot, a bowstring, a weapon, transfers its moving force to an object, e.g., a ball, an arrow, a cannonball, propelling it further. This hypothesis was revolutionary because it seemed impossible for a force to act over such vast cosmic distances at that time. The intensity of this quasi-magnetic force acting on each planet was proportional to the distance from the sun to that planet. Just as light intensity decreases as one moves away from the source, so does the mover soul. The farther the celestial body is from the sun, the more its movement diminishes. Kepler's idea of the mover soul emerged around 1600. In his correspondence, he referred to it as the mover capacity or mover force. This usage underscored Kepler's decisive break from the Aristotelian concept, as even when he spoke of the mover soul, he actually meant a force emanating from it. Although Kepler mistakenly believed this force had a magnetic nature, he described the happenings in the heavens by the rules of contemporary physics. Today, historians of science classify his mover soul as a scientific myth, but a very plausible one. Despite Kepler's efforts to justify celestial mechanics anew without considering the mass of planets or their mutual influences, the general scheme of celestial motion he depicted was accurate. Kepler's laws, derived from observations, were later used by Newton to substantiate the law of universal gravitation. Newton demonstrated that under the influence of mutual attraction, two bodies, such as the sun and any planet in the solar system, would move according to Kepler's laws. The invisible mover soul, now metaphorically speaking, became the force of gravity. One of the most significant recent discoveries in physics was the detection of gravitational waves in 2015, which earned the Nobel Prize in Physics in 2017. This discovery prompts us to revisit Kepler's magnetic force because gravity, as we now understand, propagates similarly to electromagnetic waves. Kepler's and Newton's theories, rejected and accepted, truth and myth, intersect once more. In the erroneous, the mythical, ideas are found that complete the truth. Was there a planet Phaeton? The existence of this legendary planet was long believed, supported by the supreme power of science, mathematics. The first mention of this planet was likely by Johannes Kepler in 1596, intrigued by the vast empty space between the orbits of Mars and Jupiter. This gap disrupted the celestial harmony. Kepler sought a law connecting the orbital periods of the planets. But with only 5 known planets, the law couldn't be found. So, he boldly posited the existence of 2 new planets, one between Jupiter and Mars and another between Venus and Mercury, as noted by his biographer Pritchett. In 1766, German mathematician and astronomer Johann Daniel Titius formulated an empirical rule to approximate the distances from the Sun to the known planets. These distances corresponded to a simple numerical series. Take the sequence 0, 1, 2, 4, 8, 16, 32. Multiply each number by 0.3. Add 0.4 to each result. This generates the sequence 0.4, 0.7, 1, 1.6, 2.8, 5.2, and 10. These numbers represent the distances from the Sun to the planets in astronomical units AU, where 1 AU equals 150 million kilometers, the average distance from Earth to the Sun. Today, this law is known as the Titius-Bode law, gaining widespread recognition after the work of German astronomer Johann Alert Bode in 1772. This law fit well with the arrangement of the solar system's planets, except for one discrepancy. At $2.80 for 100 million kilometers from the Sun, no planet had been found. Yet, the mathematical law demanded one. When Uranus was discovered in 1781, fitting the predicted distance from the Sun, astronomers began a systematic search for the 5th planet. Success came to Italian astronomer Giuseppe Piazzi on the night of January 1st, 1801, when he discovered a small planet named Ceres. This long-awaited discovery was soon overshadowed by new findings, pouring in abundantly. Pallas, Juno, and Vesta were discovered. Back then, German astronomer Heinrich Wilhelm Olbers, 1758 to 1840, who discovered Pallas and Vesta, suggested that all the detected small planets were fragments of a once large, disintegrated planet. Inspired by Hoffman and Chamisso, he even indulged in romantic fantasies, claiming that this planet, like Earth, was suitable for life and might have harbored its own civilization. This destroyed planet was named Phaeton, reminiscent of the ancient Greek myth. The myth told that the sun god Helios raced across the sky every day with a chariot drawn by fiery horses. One day, his son Phaeton decided to ride his father's chariot, but the horses did not obey him and headed towards Earth. Zeus then struck the chariot with lightning. Phaeton perished, the fiery horses fled, and Earth was scorched. Some enthusiasts even believe that the planet Phaeton was destroyed during ancient Greece, and the well-known myth is a poetic account of a catastrophe that shocked the Hellenes. In reality, an asteroid belt lies between Mars and Jupiter, and Ceres turned out to be just the first of many. Famous French astronomer Urbain Le Verrier, 1811 to 1877, attempted to determine the possible mass of planet Phaeton. He, like other scientists, was sure that many asteroids had yet to be discovered. However, celestial mechanics allowed the overall mass of known and unknown small planets to be estimated. Lou Verrier calculated how the asteroid belt affected Mars' orbital motion. Knowing the gravitational influence, the total mass of the asteroids could be estimated. According to Lou Verrier, it did not exceed 0.1 to 0.25 Earth masses. Other astronomers, doubting Lou Verrier's conclusion, tried to calculate Phaeton's mass themselves, finding it similarly small. Today, astronomers are even more critical of Lou Verrier's result, believing that Phaeton's mass was overestimated by at least 10 times. If one were to assemble this vanished planet from asteroids, it would be no larger than the Moon. The Moon's mass is 0.12 Earth masses. It's likely that a planet couldn't form in this part of the solar system because when Jupiter formed, it gathered all the material. Planetesimals, the building blocks of future planets, near Jupiter's orbit, where Phaeton should have formed, were scattered. Meanwhile, astronomers of past centuries even managed to study Phaeton. Contrary to calculations, it was supposedly larger than Mars but smaller than Jupiter. It was located at the edge of our solar system's habitable zone between cosmic life and death. As Olbers believed, life might have arisen there, but beyond the sun stretched lifeless space. Scientists speculated about the catastrophe that befell this ill-fated celestial body. American researcher Charles Koval suggested that 175 million years ago, Phaeton collided with an asteroid and shattered into millions of fragments, which rained down like bombs on neighboring celestial bodies for a long time. For example, on Mars, there is a crater 600 kilometers in diameter and 25 kilometers deep. Why not see the shattered Phaeton behind this phenomenon? Many of its fragments also entered the gravitational fields of Mars, Jupiter, Saturn, and Neptune, becoming their moons or part of their planetary rings. In this hypothesis, which turned into a legend, the fate of the two largest fragments was particularly interesting. For thousands of years, these sparkling fiery balls orbited the sun. Later, one of these comets supposedly became the ninth planet, Pluto. The other, according to the hypothesis of American researcher Immanuel Velikovsky, became the morning star Venus. At one time, the orbit of this comet repeatedly intersected with Earth's orbit, terrifying people. The danger was indeed real. Velikovsky wrote, though no serious scientist believed him. Earth would sometimes be knocked off its orbit, leading to apocalyptic events, earthquakes, volcanic eruptions, floods, fires. Climatic catastrophes frequently occurred, disrupting the seasons. Only around 800 BC did cosmic bombardment cease. The last projectiles scraped our Earth. Gravitational forces calmed. Since then, the comet with a fiery tail, now the planet Venus, has peacefully orbited in its path. However, the legend eventually dissipated. The hypothesis didn't withstand practical verification. Later calculations showed that the planet Phaeton never existed. Only tiny planetesimals orbited between Mars and Jupiter. Since 1983, an asteroid has been named Phaeton. It is not part of the asteroid belt, but is much closer to Earth, Venus, and its satellites. The cloudy veil long obstructed the study of Venus's surface through a telescope. Noticeable landmarks like red spots or dark seas were absent. Scientists couldn't accurately determine the planet's rotation period for some time, believing Venus always faced the sun with the same side. Only in 1961, using radar observations, did they establish that Venus does rotate, albeit very slowly. On Venus, you wouldn't say, day flew by unnoticed. A day on Venus lasts 243 times longer than on Earth. If people could settle there, any newspaper would publish an overview of events over a year. As a year on Venus is shorter than a day, it lasts 225 Earth days. This beauty, sometimes sprightly, sometimes weary, manages to orbit the sun faster than it rotates on its axis. Everything is mixed up here. Why does Venus rotate so slowly? It's possible that at one time, Venus had a large satellite. This satellite created strong tidal forces, which heated the planet. This didn't last long. After a few 100 million years, the satellite, having become as large as Mercury, left Venus. Since then, our celestial neighbor has remained a hot, slow-moving planet. Of course, this is just a hypothesis, but it hasn't been disproven yet. In 2006, a radical hypothesis was presented by Alex Alamy and David Stevenson from the California Institute of Technology. According to them, Venus collided with another celestial body in the distant past. The other body broke apart, and its fragments formed a satellite around Venus. This theory resembles the hypothesis of the moon's origin. However, after another collision with a large celestial body, Venus started rotating in the opposite direction. The satellite then began moving closer to Venus instead of drifting away like the moon does from Earth, until it eventually crashed into Venus. Confirming this hypothesis is challenging because Venus's volcanic activity has transformed its surface and erased all traces of ancient catastrophes. Interestingly, a satellite of Venus was already discovered. In 1672, Italian astronomer Giovanni Domenico Cassini, 1625 to 1712, who was the first director of the Paris Observatory at that time, noticed it. Initially, Cassini doubted his discovery and did not publish reports about it. However, 14 years later, he observed the object again and recorded it in his observation journal. According to Cassini, the satellite was large, with a mass only 4 times less than that of Venus. Later, other scientists observed the same satellite. In 1740, English astronomer and optician James Short saw it. In 1759, German astronomer Andreas Mayer, and in 1761, Joseph Louis Lagrange also observed it. Lagrange noted that the satellite's orbital plane was perpendicular to the ecliptic. The year 1761 was special because, from time to time, Venus, the Sun, and Earth aligned perfectly. During this alignment, if you look at the Sun through binoculars or a telescope, you can see a small black dot, Venus, moving across the Sun's disk. This event, known as the transit of Venus, is very rare, occurring once every 100-plus years, then repeating after 8 years before another century-long wait. For the past 2.5 centuries, astronomers have been intensely focused on Venus during this event. Their attention has often been rewarded with discoveries. On June 6, 1761, the Russian scientist Mikhail Vasilyevich Lomonosov discovered Venus's atmosphere. In that same year, 5 astronomers observed Venus's satellite 18 times. The most intriguing report came from German astronomer Abraham Schouten. On June 6, he observed Venus crossing the Sun's disk, accompanied by a small dark spot. However, British astronomer Samuel Dunn did not see the satellite near Venus on the same day. In 1764, 2 observers noticed the satellite 8 times. Others tried but failed. The debates heated up. Some steadfastly did not see the satellite, while for others, it flickered in the sky with enviable regularity. In 1766, Maximilian Hell, director of the Vienna Observatory, suggested that all observations of the supposed satellite could be explained by an optical illusion. He believed the bright image of Venus reflected off the eye's retina, reappearing in the telescope lens. This is why enthusiasts saw a spot near Venus. While some laughed at their colleagues' curious misconceptions, others wasted no time. In 1777, German astronomer Johann Heinrich Lambert, 1728 to 1777, considered one of the founders of photometry, published detailed information about Venus's satellite in the Berlin Astronomical Yearbook. Lambert introduced key concepts in photometry, such as light intensity, brightness, illuminance, and albedo, and established several photometric laws. According to Lambert, the satellite lagged 66.5 Venus radii behind the planet, the same distance as the Moon from Earth. However, this figure did not match Lambert's calculated orbital period of 11 days and 3 hours. The uncertainty surrounding Venus's satellite continued until the end of the 19th century. In 1884, Belgian astronomer Jean-Charles Hoyle proposed a surprising idea. He found a pattern in previous observations. The satellite was seen every 1,080 days, 2.96 years. Perhaps they were not dealing with a satellite, but an independent planet. Orbiting the Sun, it approached Venus every 3 years in a phenomenon called conjunction. Hoyle named this planet Neith after the Egyptian goddess of hunting and war, who was unseen by mortals. However, 3 years later, the Belgian Academy of Sciences published an extensive report investigating Neith sightings. They found that all were stars accidentally observed near Venus. For example, James Short had actually seen a star with a magnitude of less than 1/8. Observations by Urbain Leverrier and Jacques Anton were similarly explained. Copenhagen astronomer Christian Horbo likely saw the star Theta Librae in 1768. Danish astronomer Peters mistook 2 stars from the constellation Orion, and 1 each from Taurus and Gemini, for Venus's satellite. Unfortunately, all of Lambert's orbital calculations were worthless. After this revealing document was published, only one more sighting of Venus's satellite was recorded. On August 13, 1892, American astronomer Edward Emerson Barnard, 1857 to 1923, who had previously discovered the Horsehead Nebula, observed an object near Venus with a magnitude of 1/7. There should have been no stars in that position. Everyone knew Barnard had exceptional vision. Today, we do not know what he observed. It could have been an asteroid passing by Venus, or a supernova briefly shining behind Venus. In that case, it is strange that no other astronomers observed this flash, and since then, no one else has seen Neith. However, astronomers now know that Venus has a pseudo-satellite, asteroid 2002V68. This asteroid orbits the Sun, occasionally crossing the orbits of Mercury and Earth, and mirrors Venus's movement precisely due to their 1:1 orbital resonance. The second moon. In the 19th and 20th centuries, astronomers repeatedly reported the discovery of a new satellite of our planet, a second moon. Each time, these discoveries were not confirmed. This story began in 1846 when the director of the Toulouse Observatory, Frédéric Petit, claimed that his staff, Lieben and Dacier, discovered an extremely small second satellite of Earth early in the evening of March 21, 1846. After verifying their observation, Petit calculated that the second moon orbited elliptically, completing one revolution in 2 hours, 44 minutes and 59 seconds. At its furthest point, it was 3,570 kilometers from Earth, and at its closest, it was just 11.4 kilometers from the surface. Enthralled by the idea of a second moon, Petit suggested that some peculiarities in the movement of Earth's primary satellite could be explained by this tiny planet's influence. However, astronomers largely ignored his discovery. It might have been forgotten if not for the mid-19th century's popular writer Jules Verne. Verne read about the second moon's discovery, and it significantly impacted his character's fate in his 1869 novel Around the Moon. In the novel, a projectile, a spaceship, launched towards the moon became its satellite. The heroes seemed trapped, but they encountered a small celestial body, the second moon. "Is such a thing possible?" exclaimed Michel Ardan. "Earth has 2 satellites." Yes, my friend, it has 2 satellites, although it's commonly believed to have only one. This second satellite is so small, and its speed so great, that Earth's inhabitants cannot see it. Only by observing the disturbances it causes, the French astronomer Monsieur Petit discovered its existence and calculated its orbit. "Do astronomers acknowledge the existence of this satellite?" asked Nickel. "No," replied Barbicane, "but if they, like us, encountered it up here, they could no longer doubt it." Their encounter nearly led to a collision with the second moon. Although it did not occur, the projectile altered its course and eventually returned to Earth. Millions read the popular sci-fi novel, remembering this important scene and the supposed discovery by the French astronomer. Others continued the search. In 1798, George Waltemath of Hamburg reported discovering a system of tiny Earth satellites, specifying the exact parameters of one. It had a diameter of about 700 kilometers, was located 1,000,000 kilometers from Earth, and completed one orbit in 119 days. According to Waltemath, this satellite is sometimes mistaken for the Sun. He referred to the American polar explorer Adolphus Greely, who in October 1881, while in Greenland, allegedly observed the solar disk for 10 days after the polar night had set in. Waltemath also predicted that on February 2nd or 4th, 1898, the second moon would transit across the Sun's disk. His forecast drew interest. On February 4th, the post office in Greifswald, Germany, turned into an observatory. A dozen viewers, including Postmaster Jägel, his household, and colleagues, gazed at the dazzling sun, trying to assist astronomers. The sunlight burned their unprotected eyes, but they persisted. They clearly saw a dark spot slowly moving across the sun's disk over an hour, about 1/5 the width of the sun. Was the discovery confirmed? Not really. It was soon revealed that at that exact time, 2 experienced astronomers, Winkler from Jena and Baron von Benkow from Pola, Austro-Hungary, were also observing the sun, but saw nothing unusual except ordinary sunspots. Thus, the discovery turned into a mistake. However, Waltemath did not give up. He repeatedly predicted where the second moon could be found, but it always eluded observation. In 1903, American astronomer William Henry Pickering inadvertently organized a search for this tiny planet by publishing an article on the photographic search for the moon satellite. Everything said about this hypothetical object could apply to observing the second moon. His article stated that a 30-centimeter satellite at a distance of 320 kilometers from Earth's surface could be seen in a 3-inch telescope. A 3-meter satellite would be visible to the naked eye. If it wasn't visible, its diameter must be less than 3 meters. It's worth returning to Petit's idea that the second moon affects our primary satellite's movement. This could only be true if the second moon had a diameter of several kilometers, but then it would have been noticed as far back as Babylon. In 1922, Pickering published another article in the same journal, dedicated specifically to the second moon, calling it a meteorite satellite. Enthusiasts were excited because it suggested that a 3 to 5-inch telescope with a low eyepiece was best for searching for the satellite, a task for amateur astronomers. Just a few years later, the German astronomical journal Die Stern reported that German amateur astronomer Spittel discovered such a satellite on May 24, 1926, during its transit across the moon's disk. But this discovery, like others, did not lead to further observations. The search for the second moon even brought astronomy closer to astrology. In 1918, English astrologer Cephariel Walter Richard Old named the celestial body Lilith. Old believed it was black, making it unobservable with astronomical instruments. Only when this black moon crossed the sun's disk could it be seen. He also claimed that Lilith's mass was equal to the moon's, not considering that such a massive body should affect Earth's movement. Let's set aside astrologers and note that perhaps Petit, Spittel, Waltemath, and their colleagues were not entirely wrong. They may have discovered short-lived satellites of Earth. Sometimes, our planet captures small passing bodies, meteoroids. They orbit Earth for 100 to 150 hours, dipping into the upper atmosphere and gradually losing speed. After a few orbits, these bodies, mistaken for a genuine satellite, disintegrate, leaving astronomers puzzled. Some scientists also believe the moon occasionally captures small nearby boulders. Calculations show that within a few years, such a satellite would inevitably crash onto the moon's surface, potentially surprising stargazers. The search for a second moon continues today. In 1997, Canadian astronomer Paul Wiegert noticed a small asteroid, 3753 Crothin, moving in a peculiar orbit. It appeared to be a satellite of Earth. However, observations revealed it wasn't a permanent satellite, just a temporary companion. Similar pseudo-satellites, like 2002AA29, 2003 YN107, and 2010 SO16, have been encountered by astronomers. Thank you for watching. If you enjoyed the content and want to see more, please give this video a thumbs up and subscribe to our channel. Your support helps us create more great content for you. Hit the notification bell so you never miss an update. See you in the next video.